Okay, let's get into exponents and radicals. Okay, if you were to read this, what is it you would say? What would you say? Some people may say n to the second. Some people may say n to the power of 2. But that's actually probably not what most people would say. They would say n squared. Why? I want you to think about that. Why do we say n squared? Well, let's think about the shape square. A square is an isosceles, parallelogram. But in other words, we've got a quadrilateral with 4 sides that are the same. Okay, so the equation of a parallelogram is going to be base times height, and my base and my height are the same exact thing. So my area will be n squared, and that is why we say square. Okay, same thing with cubed. N cubed is n times n times n, and the area of a cube will be base times height times width. Not the area, excuse me, the volume. The volume of a cube will be n cubed, side cubed, okay? The area of a square is side squared. The area of a cube, the volume, keep doing that. The volume of a cube is side cubed. N to the first is just n. We can think about this geometrically as well as a line segment of n. What about n to the 0 power? You probably know that this is 1, but I want you to think about why. Why is that 1? Well, let's think about it, okay? So as we go up in powers, right, we're multiplying by n. And as we go down in powers, we're divided by n, right? So if I have n cubed, and I divide this by n, you know, you may do something like that, right, to get n squared. Well, you can also look at it like this. N cubed divided by n is the same thing as n to the 3 minus 1. This is 1, and it's, as you divide by an n, as you go down an n, you are going to subtract 1 n, okay? Or in other words, n cubed. All right, so then if we think about that when it comes to n to the first divided by n, well, this is also just n to the first, right? So this is going to be n to the 1 minus 1, or in other words, n to the 0. Well, anything divided by itself is just 1, right? To kind of summarize this, if you're, you know, for your notes, you can think about it like this. N to the x times n to the y is equal to n to the x times y. All right, you can also do n to the x divided by n to the y will be equal to n to the x minus y. This should be a plus, excuse me. There we go. All right, hopefully that helps with your notes. Let's think about this geometrically as well. So what is 1 represented geometrically? Well, it's a point, right? Okay, what about n to the negative 1 power? Well, let's think about it. N to the 0, right, is going to be 1 divided by n. So it's going to be, we could say that this is n to the 0 minus 1, or in other words, n to the negative 1. Well, n to the 0 is 1 divided by n, so this is just going to be 1 over n. This is the reciprocal. The reciprocal, right? Now, you probably know this already, but I really want you to get at the y, all right? On your calculator, you may have a 1 over x button, or you might have an x to the negative 1 button. These will do the same thing. They're just going to find the reciprocal, okay? So if you have 3 over 2 and you need to get to 2/3, you're going to press this button, right? Right. Okay. What about n to the 1/2 power? What is that? Well, you may know that this is the square root of n, but I'm going to try really hard to explain this, and I find this is kind of hard to explain. So bear with me here for a little bit as I try to explain this. So let's say we have n plus n is equal to m. We can also represent this as n times 2 is equal to m, right? We could also say that m minus n is equal to n. We could also say m times 1/2 is equal to n, right? Now, if you're in calculus, or when you take calculus, you're going to learn about derivatives, and this is a way to understand derivatives. But if you're not in calculus, I still want you to understand this, okay? Addition, let me put it this way. Powers are to multiplication as multiplication is to division. Roots are to division as division is to subtraction. If that makes any sense. All right, so let's go ahead and upgrade this, right? Okay, so then we could say, well, let's just upgrade all the operations here. So n times n, well, let's say that this is true. We could also then say that n, we're going to upgrade it, n squared would be m. We could say that m divided by n is equal to n. See, we're just one operation up. And then we could also then say that m to the 1/2 power is equal to n. Do you see how that works? Okay. You could also say here that m divided by 2 is n, and the same thing here. So m root 2, or the square root, is n. All right? It's just a pattern. It's just a pattern, okay? Great. So then what is n to the 3 over 2? Well, if we follow that same pattern, if we look at it this way, this is just going to be n cubed, the square root of n cubed. Okay, so to kind of summarize that, it's going to look like this. Let's say I have, I got to come up with another letter here. So let's do x to the y is equal to z. X to the y over w is equal to z. And then we could say that z would be equal to the w root of x to the y. Okay? All right. I can't represent a fractional power or a root or a negative power geometrically. At least I can't conceptualize of it. But you can think of, you know, n to the 0, n to the first, n squared, and n cubed as a dimension. You know, you see that? We're going up in our dimensions here. Okay, so let's go ahead and try to model this. That's a really good thing to do anytime you're trying to understand a new concept is just to model it. Unfortunately, Zoom doesn't let me, not Zoom, Desmos doesn't let me write on their screen. So let's go ahead and do this. All right, so let's think about f of x is equal to 2 to the x. And how is this going to play out? Okay, so then let's say we have x and f of x. Okay, so if x is -1, f of x will be 2 to the -1 power, which will be 1/2. Okay, if x is 0, f of x will be 1. If x is 1/2, f of x will be the square root of 2, or in other words, it's approximately 1.4. 1/2 That looks good. Okay. If x is 1, f of x will be 2. Let me make this a little darker. Okay. Okay. If x is 3 over 2, f of x will be 2 cubed, the square root of 2 cubed, or in other words, the square root of 8, which is approximately 2.4. 3.5 be 2. I'm sorry, it's actually 2.8. Right here. If x is 2, f of x will be 4. And if x is 3, f of x will be 8. This makes, let's see how well I can draw it. This makes an exponential graph. Okay, so let's see if we were right. We were. Okay, so -1 power, 0.5, 0, 1, 1/2. .4, square root of 2. Let's do 1.5, 2.8. There, okay. Or the square root of 8. Here is 4 and 8. Okay. All right, so exponents and radicals.